Hello, Thiago. Hello, Mike.
Hello, Caio. Hello, Mike.
Hi, Thiago. Hi, Caio.
Thank you for joining us.
Thank you.
So, are you an iOS developer?
Yes, I am.
For how long?
I've been working with iOS development since 2016, so it's 5 years.
Awesome.
And before that, were you a developer?
Yeah, I started with Android development because I was a Java developer before that, so it was the easier path. Then I decided to move to iOS development.
Awesome. And how can we help you?
So, regarding threads and concurrency, I haven't seen much thread and concurrency handling at any level in most projects that I've been through. The only usual handling is when you have something to send to the view controller. So you use the main thread handling. So my first question is, what is the best approach regarding thread handling and concurrency? Which type of handling should I use, and which are the most common situations to handle threads and concurrency?
Okay. Threads and concurrency. Best way. And the other one you said is the...
Which are the situations, the scenarios that I need to handle threads and concurrency?
Yeah.
So you mentioned that you usually don't see it in the projects you work on, like proper handling, or you don't see it at all?
Yeah, at any level. The only thing that I see, it's when you have to send something to the view controller. So sometimes you see the main thread handling, but it's not the usual. I'd say in 95% of the projects that I've been through, you don't see any level of thread and concurrency handling. So I think the app works fine, but you may have some problems, some issues sometimes. So I'd like to know more about this so I can handle better those situations.
Yes, if you don't handle threading accordingly, you will have issues, or concurrency in general, right? So I'm pretty sure every app you ever worked with uses threads behind the scenes, because iOS apps, they are multi-threaded, right? It's how the platform works.
Yeah.
So you're using threads and you are performing code concurrently in your applications.
Sure.
Because like traditionally, instructions in a code instructions are executed serially, right? Line by line. First this happens, then this happens, then this happens, then this happens. But if you run one instruction at a time only, one at a time, what happens when we have a long-running operation, like a network request, that can take 5 seconds to complete? It's going to run line 1, 2, and then it hits the network request, and it's going to wait 5 seconds and then go to the next line. And you don't want that, right? Your whole app will be unresponsive while you're running the network request if everything is running sequentially in the same thread of execution. And that's where threads come in. A thread of execution is just a sequence of instructions that can run independently from other sequences of instructions, from other threads of execution. For example, you can run the network request independently of the UI updates, right? You're still interacting with the UI and the request is running in the background, right?
Right.
And it's running in a separate thread of execution that is scheduled by the system to run concurrently. So you can run code concurrently without blocking each other if you separate them, and you can run those instructions independently. And the system will schedule for you when it's going to process one thread or the other. You don't need to be concerned about that, because This is going to be dependent on the hardware. If you have multi-cores, if you have a single core, depending on the operational system, depending on capacity, depending on how many things are running, priorities, and so on. All of this is very complicated logic. So threads is an abstraction on top of this hardware and OS scheduling.
Okay.
Right. So threads executions are independent pieces of code that can be run scheduled concurrently by the system. Make sense?
Yeah, but I mean, I can't see. I don't see any declared thread handling. You're saying that this happens all in. You don't need to implement the thread handling, right? Actually, you need to, but this can happen without implementing it. I mean, you can have like an API call, then you have, for example, a delegate, and every time the API call finishes, then you can use the delegate to send something to the view controller, and you can do that without any declared, without writing any thread handling at all.
Not really. Well, nowadays, it's rare to use threads directly, right? You don't usually detach a thread like this anymore. That's how we used to do back in the day.
Yeah.
Actually, before even blocks existed in Objective-C, we would use the thread, attach a new thread with a given selector and target. And this would create a new thread and call your code in that separate thread of execution. And the system would schedule when that would be run for you. Nowadays, you don't interact with threads directly. You can still do it, you see? You can still do it. But there are other abstractions on top of thread that you use, like dispatch, the dispatch framework, or before that, GCD. So if you've been working for 5 years as an iOS developer, you probably use Objective-C at some point.
Yeah.
Remember GCD, like dispatch, queue.
Yeah.
Nowadays, we use in Swift the dispatch framework. So dispatch GCD and dispatch queues, dispatch groups, they are built on top of threads. So you don't interact directly with the thread, but behind the scenes, every time you're using a dispatch queue, you are interacting somehow with a thread indirectly.
Okay.
Because dispatch queues, the dispatch framework, they are abstractions on top of threads. Behind the scenes, there's still threads. They'll be scheduled by the system to be run concurrently. But when you're dealing with queues, for example, you're using queues instead of using threads directly. And behind the scenes, the queues will use threads to schedule the work. But you don't need to think about threads when you're using queues.
Okay.
You know, the system, the dispatch framework will use the appropriate threads for you. The only special queue is the main queue that is attached to the main thread. It's always guaranteed to execute in the main thread. But any other queue can run in any thread. You don't need to be concerned about which thread this is going to be run in.
Okay, good.
So it's an abstraction of threads, but there are threads behind the scenes. Like when you use URL session to perform a network request, you are using threads as well behind the scenes to execute that in a separate thread of execution.
Good. Okay.
So when you run like a URL session, beta task, you get a completion block, shared. Yeah, let's say you pass a request. This block here, by default, is called in a background queue. Unless you tell it to execute in another queue. And if you just get this result here and update the UI, you have runtime issues, runtime errors, because the UI can only be updated in the main queue.
Yeah.
And when you dispatch to the main queue here, dispatch queue, let's say main async, right? behind the scenes, there are thread work going on, because the main dispatch queue will run the work in the main thread.
Right.
It will schedule all its work and execute its work in the main thread, where you can update the UI. So you are using threads every day. You just don't interact with them directly. And if you do this wrong, you have runtime issues. Like trying to update the UI in a background queue, in a background thread. Make sense? The overview of threads and queues.
Yeah, totally.
And concurrency, right? In general, running things in parallel, they are independent of each other. So what is the best way of dealing with threads and queues? Ideally, in a centralized place. Because if you keep dispatching work for to different threads or different queues everywhere, it's very hard to keep everything in sync.
Yeah.
To reason about the whole system, because you never know in which thread you are in. You need to always be concerned about, like, should I dispatch the main queue now? Should I dispatch this to a background queue? That's why if you put threading code everywhere in your views, in your view controllers, in your networking, in your view models, it's going to be very hard to reason about your system, because there's threading code everywhere. So ideally, you want to centralize that, make all your components decoupled from threading, and make sure to send the messages to your components in the right threads when you compose them. Especially when you have mutable state. What is the enemy of concurrency? What's the enemy of concurrency? Mutable shared state. So the enemy of concurrency is mutable shared state.
That's
Why?
it.
Let's say you detach two threads here, and you have some mutable state. Var state, let's say it's a string. In this thread, you set the string to 1, and this thread you set it to 2. Remember that threads of execution are supposed to be independent sequences of instructions. Now, is this an independent sequence of instructions? No, because it depends on something that is shared between other threads.
Okay.
If you create more than one thread operating on the same mutable state, they are not independent anymore. They have some shared resources. And when you have shared resources, you need to synchronize access to it. Because if two different threads of execution running concurrently try to mutate to the same state, you will have runtime errors, runtime issues. You cannot change the same state at the same time. Your app will crash. It's not allowed. It will corrupt the memory. Thus, your app will crash to preserve the integrity of the system. So the best way to handle threads is to create as much as possible code that is not sharing state, that is independent, fully independent. Thus, you can execute them, schedule them separately, and not be concerned about it. And the best way I know to do that is to design your codes to be decoupled from threading. And when you compose them, you inject the threading from a centralized place where you can reason about your whole system from a centralized place. You look at that and you know exactly what's going on from one single place. So eliminate shared state is the best way to not have issues with threading. And you can use patterns like decorator to inject threading into your composition. You can use combine operators like receive on, subscribe on, to also help you manage threading. So if you're using a framework like Combine or X-Swift, you can use those operators, or you can use decorators.
And all these things, by the way, they are in the program, right? Like
with many examples.
Yeah, gonna see them there. So
have you finished?
Yeah, where are you?
How far in the program?
I'm in progress.
Yeah, so just follow the lectures in order and
yeah, sure.
Like our recommended way of dealing with threading, which is to decouple it from everywhere. Because it's very easy to put dispatch queue calls like this everywhere in the view controller, in the view models, in the networking, and so on. And you keep it in a centralized place. And then you don't need to dispatch your code everywhere defensively. And you will eliminate a lot of threading issues because you can reason about threading from a single centralized place, which is much easier to, you can literally see in a single file how the threading is handled. And I find it much easier to manage this way. We also cover threading, operations, and queues in the mentoring session 13.
Yeah.
It's in the academy. Go there in the academy, go to the mentoring sessions page, and the mentoring session 13.
Okay, good.
Session 13.
Yeah, multiple techniques as well on this one.
Thanks. An overview of threading, concurrency, our recommended way of dealing with it, and situations and scenarios you can use. We use it is when you want to detach some long-running operations for not blocking the UI, for example. If you're making a database call, or if you're performing like some kind of search in a large data set that will take some time. Anything that you want to detach, any independent operation that can be run in a separate thread of execution without blocking other clients.
Good, got it.
But you've been using threading, but not directly. But every application, every iOS application uses it.
Yeah, for sure. My question was, and you've mentioned that more about that thread controlling that you can see. I mean, that's not an abstraction, but
right.
I think I got it.
It's very hard to reason about threads, and that's why they created another abstraction. Because it was very hard to schedule work in a computer because of different hardwares, because of different processors, because of different like priorities. Does every operational system have to have their own scheduling system? And you need to have an abstraction. So when you're writing your code, you don't need to know which operating system you're using, which hardware you're operating on. Thus, they created this abstraction called threads of execution. Now, it's hard to reason about threads. You cannot create a lot of threads. If you create too many threads, you have issues as well, because there's a cost for creating threads. There's a limit of how many threads you can run in your system. So, and it was very easy for people to abuse it and create too many threads and start having issues at runtime. Does it create another abstraction on top of that, which was the dispatch framework, GCD first, and then the dispatch framework. So you don't need to talk directly with threads. So you will, try to eliminate more issues, misusage of the threading APIs. And coming next, async await, which is another way of designing your system and composing asynchronous operations.
Yeah. It's a good one.
We'll see.
Maybe in 3 years we can use it.
Yeah, that's the same thing, at least in the projects that I've been. Swift UI, you don't see that much in old code bases. So not old code bases, but like apps from 3 years before today. So everyone is avoiding moving to Swift UI because, especially because of the iOS version.
Yeah, iOS 14 introduced a bunch of updates to Swift UI that made it pretty much production ready. But we're still supporting like iOS 12, like 11 sometimes.
Yeah. That's true.
Yeah, so maybe, but there's a lot of apps already in Swift UI. So I believe like in 2 years, Swift UI will be there, but maybe async await is going to take longer because it's iOS 15.
Yeah, probably. It's getting usual.
Times doesn't stop, so we'll get there eventually.
Nice. That's true.
Any other questions?
Yeah, actually, regarding delegates and closures, I'd like to know if is there a better way to wait for some asynchronous request? Well, is it better using delegates? Is it better using closure? Is there another approach to handle those requests? And is there any kind of performance difference between those approaches?
Okay.
First of all, which one is best? Depends in which context.
Yeah. Exactly.
There's no best. If closures were best, no one would use delegates, right? So there are use cases for both. So you mentioned in async operations, right? Usually, like most new Swifty APIs, like URL session, they are closure based, right? You get the callback here with a closure, completion closure. It makes it handy. Like as a framework creator, as Apple creating a framework, they want it to be easy to use. It doesn't get easier than this, right? So their goal here is ease of use, right?
Right.
But they also provide delegate.
Yeah.
Because here we have, let's say we have here a URL, response,
It's a response. Yeah.
and error, right? This is the data task completion block. So this is a convenience. A data task, URL session, data task, also has a delegate. Task, delegate. Where is it?
Yep.
What's going on? My documentation. Here. They also have a delegate. And you can choose to use either the delegate or the closure based. They give you two choices. So it's up to you to decide. They give you the convenience of the closure if you want to get the result directly from the caller, or they give you the delegate if you want to decouple the caller from the result.
Yeah.
Now, I like the foundation APIs because they give you both options. And then it's up to you to decide. But some frameworks only give you the closure or only give you the delegate. But here, you could also use the closure. And as you can see with the delegate, you get many more different callbacks. You get a callback in the task. If we'll begin delayed, is waiting for connectivity. You have many more different callbacks.
Yeah. So that will be hard to, like have it in closure form.
You have to define one closure for each operation.
Yeah.
Now look at how many parameters this one takes. So you have to define a closure with 4 parameters. I mean, it works. You can do it.
Yeah. Yeah, it depends. Like that's the answer.
So imagine you have a view controller using the URL session and making a request, right? And it's using the closure-based completion callback. Here you have a URL. Any.com. Okay. The same client that made the request. So imagine I'm calling this method, right? So
Right.
the same client that calls that initiates the request needs to handle it, because I need to pass also the closure to complete it, right?
Right. Okay.
So if you're using the closure-based completion directly in the method like this, you couple the client that is calling, that's telling you to execute the request, from also handling the result of the request. But with a delegate, you can decouple that. And let's say the view controller that tells the request to start doesn't necessarily need to be the one that will handle the request, because you can have another object, another instance, implementing the protocol and handling the delegate method. So when you want to decouple the client that initiates the request from the one that handles the response, you can use a protocol. Or you can also use a closure, but it shouldn't be a parameter in the caller method. For example, if you have a UI table view controller, class table view controller, UI table view controller, build it load, and you have a table view, right? In the table view controller, and you can call reload data.
Okay.
So I'm telling the table view, hey, reload your data, and then the table view will call its data source to provide the data, right? And the data source, in this case, can be self. And then you implement here like number of sections. And here you can return 1. And this, you tell the table view that you should render 1 section. But since calling the method and handling the data source operations are in separate properties, I don't have to say reload the data and pass a closure here to return 1, right? So I can move this logic here to another component, implement the UI table view data source, implement this method, that data source equals data source, and now I can say, hey, I am the one that tells the table view to reload the data, but I'm not the one that will provide the actual implementation of what this data should look like. Make sense?
Yeah, totally.
That's it.
More than a architecture decision.
Absolutely.
Yeah. It starts to make sense when you stop thinking that every data source equals self, like not all delegates equal self,
Yeah.
And in the same way here, if you want to decouple the view controller from actually handling, you just want the view controller to initiate the data task, but you want someone else to actually handle the response, parse it, save it to a database or something like this. You can create another like request delegate to implement the URL session data task delegate, and then implement the methods here that you want. And then here you can just create a data task with URL. Data task with URL actually.
Yeah.
Can you see that now we don't need to pass the completion? But then you can set the delegate, create your own separate session. You can have its own URL session delegate. And then you don't need to access the shared one. You can pass, let's say if you have a view controller, you pass, I don't know, your session, and then you inject your own session with its own delegate, and then the view controller just starts a request, but doesn't need to handle the response, for example.
Okay.
Now, this is not a property of protocols. You can also do the same thing with closures. My point is that if the closure is in the method invocation, then you couple the client with handling the response.
Yes.
But if you have a delegate like this, you can decouple that. But if this data source was a closure, just like the new APIs, you have the data source, diffable data sources, right?
Yeah.
It's all closure based. It's not protocol based. Cell provider.
Yep.
Which is a escaping closure that passes a table view, an index path, and the item identifier, and you need to return a cell to it. There it is. So again, this is the UIKit framework now providing you two choices. You either use the UI table view data source protocol and you implement it and provide the details, or you can use this type here, which is closure based. So everything you can achieve with protocols, you can achieve with closures as well.
Okay.
But some things are easier with closures wrapped into a type like this, like using generics. If you have generics in a protocol, you need to use associated types, and it's a headache. So sometimes it's easier to use like a class that takes disclosures or a struct, because then you can define the generic types in the type definition, whether as an associated type in the protocol. So it really depends on what you're trying to achieve.
Yeah.
But everything you can achieve with a protocol, you can achieve with closures.
Okay.
And this delegate versus closures is, as you said, an architectural decision if you want to couple the client with handling the result as well by passing a closure as a parameter in the method invocation, or if you want to separate that and inject it.
Yeah, makes sense.
But there's no which one is best. It depends, as always.
Make sure you watch a mentoring session we released last week, I believe. It's exactly on this topic. It's about protocols versus closures and when to use them, like trade-offs, all that stuff. So it's a good one.
True. Yes.
Nice. Very good.
This is the title of the last session we released. Understanding Swift closures and pros, cons over protocols and delegates. That's perfect. Check it out.
Good.
Any other questions?
No, I'm good.
Awesome. Does it make sense?
Yeah, totally. And this helped me to understand better the thread control and the concurrency and closures and protocols.
Awesome. And finish the program for sure.
Yeah. I'm in progress. I started, I think, last month. This is helping me a lot, and I definitely had like a jump in my career, in my code, and everything has improved since then I started the lectures.
Awesome. Good to hear.
Absolutely. Thank you so much, Thiago, for joining us.
Thank you, too. Thank you so much.
Thanks.
Bye. Take
Bye
care.
bye.
Hello, everyone in the chat.
Any questions?
Can't we pass references of closure to data source class? Yes, you can.
Yes.
Assigning delegates is not also coupled code. No, because you can assign the delegate from the composition root. You don't need to assign it inside the view controller.
Yes.
And of course, you can also replace this delegate with a closure. If you have a delegate with 3 methods, you would have probably 3 closures, right?
Yes.
And then you need to inject each closure at a time. But gives you more flexibility, because then you can inject different closures from different objects. You don't need to have one object implementing all the closures. If you have 3 closures, you can have 3 objects implementing one of each. But if you have one protocol with 3 methods, you need to have one class implementing these 3 methods. So it depends what you're trying to achieve. Is there any difference in performance between RX Swift delegates and closures? It depends. Like RX Swift is probably more levels of indirection. Every time you add another operation, there is a bunch of other objects instantiated and composed. So you may have a performance difference, but it doesn't mean it's going to be noticeable. So you need to measure before optimizing. Also, closures. If you have very complex closure types, the compiler will have a hard time figuring it out. You might even have problems at runtime because the compiler cannot optimize calling those closures efficiently. Usually it can better with protocols because it has more information about the types at compile time. So it can optimize more the code. But it's not a given. You need to actually measure before optimizing.
Exactly.
All right.
That's it. Bye, yo.